This was a pop quiz which was related to SI quantities, units, and the graph interpretations. So which quantity is either a scalar or a vector, and which row, a quantity is either a scalar or vector, which row is correctly showing the position of these quantities? So when we talk about energy, energy is a scalar quantity, and momentum is a vector quantity. So that's why A will be the right answer. Displacement is a vector quantity, acceleration is a vector. Time is a scalar, mass is a scalar. Velocity is a vector, force is a vector. So in A, it's correct. Which of the following is SI unit of momentum? First, whenever you want to write the SI unit, first write the formula. So what is momentum? Momentum is a product of mass and velocity. What is the SI unit of the mass? Kilogram. And what is the SI unit of velocity? Meter per second, or ms minus 1. So this will become kg ms minus 1. So A will be the right answer. Which of the following is a vector quantity? Efficiency? No, it's a efficiency is a comparison, not a like a quantity with a unit. It's just a percentage or what proportion is a useful one. Kinetic is a scalar, power is a scalar, weight is a vector quantity. Which of the following is SI unit of the stress? Stress is like pressure, and pressure is what? It is force acting on unit area. What is the unit of the force? Newton. And what is the unit of area? Meter. Area is meter square. But we need SI unit here. Newton per meter square. SI unit of the stress is Pascal, or we want the base unit. Now what about the base unit? What is the base unit of the force? The Newton. Because force is F is equals to ma. So it is Newton itself is kilogram, meter. So kilogram, meter, second minus 2, that is force. And this will be meter square. So when we check, like this, cancel with this. So this will become kilogram, second minus 2 over meter. When we further simplify, it should be kilogram, second minus 2, meter minus 1. But there is no option of kilogram, second minus 2 and meter minus 1. So means it cannot be A. So then we are left with Newton per meter square. So Newton per meter square, that is D. So that's why D should be the right answer. So we check the base unit, but it does not match with any base unit. That's why. Which row of the table only contain the vector quantities? Acceleration is a vector, momentum is a vector, weight is also a vector. So A should be the right answer. Which of the following is a scalar quantity? Displacement is a vector quantity, moment turning effect is a vector, weight is a vector, so power is a scalar. So question 6, C should be the right answer. Which of the following quantity is a vector? Energy is a scalar quantity, mass is a scalar, momentum is a vector, power is scalar. So 7C should be the right answer. Two forces x and y acting at a point, which of the following vector diagram shows the magnitude and the direction? So if you want, like, if two forces are there according to vector addition rule, first, like example, if it was x then y, like if this was x and this is y, so the resultant is from x to y. That will be the resultant. Say example, resultant is r or z, any number. And if we use a parallelogram method, like if we consider two x and y, the two forces are like a parallelogram, then what should be the resultant? So resultant should be the diagonal of the parallelogram. Like when we complete the parallelogram, that should be the resultant. So when we check this, if this, like this is the starting point, if they are sides of the parallelogram, then when we complete a parallelogram, the resultant should be the diagonal. So this is not correct. What about B? These are the sides. If these are the sides of the parallelogram, so when we complete a parallelogram, the resultant is a diagonal. So when we add x and y, so what will the resultant? From tail of the first to the head of the last, that will be the resultant. So this is correct. So if you are using a triangle method, then first vector, second vector from tail of the first to the head of the last, that will be resultant. But if you are using a parallelogram method, then the diagonal should be the result. Which of the following is a scalar quantity? So force is a vector, momentum is a vector, velocity is a vector. So work is a scalar quantity, does not have a direction. The diagram shows a student during a parachute jump on a windy day. The vertical component is 5 and the horizontal is 8. She descends at an angle of theta. Angle to the vertical. So first we complete a diagram. Like if this was 8 and this is 5, you can draw any one of them first. So 8 meter per second and 5 meter per second. So the resultant velocity, if you use a triangle method, this will be the resultant velocity. And angle with a vertical, this is one way, or you can also work out, you can draw 5 first and then you can draw 8. So 5 meter per second, 8 meter per second. So the resultant will be tail of the first to the head of the last. That will be the resultant. And the angle with the vertical means here we have a theta. So with first, to get the resultant, we use a Pythagoras, the magnitude of the resultant. We use a Pythagoras theorem. It's a base square plus perpendicular square in a root. So 5 square plus 8 square in a root. So A and B are totally wrong. So C or D can be an answer. Then, now this is a right angle triangle. And for this right angle triangle, we have to label the parts. So angle is, this one is a hypotenuse, the resultant is a hypotenuse for a perpendicular vector. Angle is always between the base and the hypotenuse. So if one side is a hypotenuse, this will be the base. And the opposite to the angle is a perpendicular. So here is a perpendicular. So which trigonometric ratio can be used? Because we have sine theta is perpendicular over hypotenuse. We have tangent theta or cosine theta, base over hypotenuse. And we have a tangent theta, which is perpendicular divided by base. So So if we use tangent theta, perpendicular is 8 and the base is 5. And we, if tan move other side, it changes to tan inverse. So tan inverse 8 by 5. So the angle will be tan inverse 8 by 5 and the resultant is 8 square plus 5 square in a root. Is it clear? Discussion? Question 11, which physical quantity may be vector, physical quantities may be scalar or a vector, which row is correct? Force is not a scalar, force is a vector, mass is a scalar, acceleration is a vector. So vector, scalar, vector. So it matches with option D. And 12, which row of a table contains the two units that are not equivalent? So when we check joules per second, because look, what is power? Power is energy divided by time. So energy is in joules and time is in seconds. So joules per second, and we also call it watt. So these are equivalent, means same. Newton second. Newton is, what is Newton? Newton is kilogram meter square second minus 2. That is Newton, kilogram meter square second minus 2. Multiplied by second, so this will become kilogram meter square second minus 1. So this is kilogram meter square second minus 1. So Newton second is not equivalent to this. So that's why B is the right answer. What about C? C is correct. Both are, but how they are equivalent to each other? Because Newton kilogram inverse. What is Newton? Newton itself is kilogram meter second minus 2 and multiplied by kilogram minus 1. So this kilogram minus 1 and kilogram will cancel. So we are left with ms minus 2. So means they are equivalent or same. Newton meter, because that's the unit of work or the energy. Force is Newton and the distance is meter. So Newton meter is also known as the joule. So they are equivalent, same. But this one is not equivalent, like the Newton second is not equal to kilogram meter second minus 2, it is second minus 1. So this was pop quiz 1, which was related to SI quantities, units in the graph.